In this video, we will try to complete parts of the Excel project for Unit 6 in our Statistics OER course pertaining to the central limit theorem. We want to click on the project instructions to read the PDF with the instructions, and also click on the Excel file and download the Excel file, and then either open it on our desktop app or upload it in OneDrive and work on it from there. I will be working on the app for this example, for this time, and by now we have seen how the Excel Online will also do the same work. So you can follow along regardless of which modality you use for Excel. So this assignment requires us to use the normal distribution app in Art of Stat to calculate probabilities and percentiles, and then use Excel functions to calculate the same probabilities and percentiles. For question 1, we are presented with a problem in a study reported on October 29, 2012 on the Flurry blog. The mean age of tablet users is 34 years. Suppose the standard deviation is 15 years. If 100 tablet users were surveyed, first describe in English the random variable we are investigating. So the random variable is the question that you will ask when you are surveying your observational units. And the question here would be, what is your age? So the variable we are investigating is the age in years, age of tablet users in years, or just age in years. That's the variable. The tablet users are actually the observational units. So they are determined by the population that we are investigating, but our variable is just the age. And after that, the instructions are directing us to enter the mean, the standard deviation, and the sample size in cells C2, C3, and C4. The mean is 34 years, the standard deviation is 15 years, and 100 tablet users were surveyed. So 34, 15, and 100. Part C is asking us in cell B6 to describe what the distribution of the mean ages will look like and why. And we know from the central limit theorem and the law of large numbers that if we have a sample size of 30 or more observational units from the population, then the distribution of the sample mean will be approximately normal. So here we are going to write the distribution is approximately normal because the sample size n is 100, which is greater than 30. The next part, D, from question 1, says that in C10 and C11, we will use Excel formulas and cell locations to calculate the mean and the standard deviation of the distribution for the sample means. To calculate the square root of n, we will use the Excel function sqrt of the location for n. Remember here you want to use cell locations. Now remember that the sample mean follows a normal distribution. Let's see if we can find that in our final exam formula page. So the sample mean follows the distribution, a normal distribution that has a mean equal to the mean of your population and a standard deviation that is called the standard error equal to sigma divided by the square root of n. So here for the mean of the sample mean age of tablet users, also measured in years, this mean will equal the mean of the variable, which is the age in years. And the standard deviation of the distribution of the sample mean will equal to the standard deviation of the variable divided by the square root of n, which is located in cell C4. So my answer is here at 1.5, and this concludes question 1. Let's double check. Yes, so we are all set for question 1. In question 2, they are asking us to use the normal distribution app in Art of Stat to find the probability the age of a randomly selected tablet user is more than 30 years. So let's try to do that. Okay, Art of Stat right here. So I'm gonna go in the online web apps. I'm gonna go to the normal distribution. I will go to find probability. I will update the mean to be 34, and I will carefully read the question. Are they asking me for a sample mean, or are they asking me for one individual? So it says to find the probability the age of a randomly selected individual tablet user is more than 30 years. So the individual tablet users, we have a mean age of 34 and a standard deviation of 15. Usually, in populations, the ages, heights, natural phenomena appear in a normal distribution setting. So here they have not told us exactly that the population follows a normal distribution. We will assume that it does because ages and heights and things that appear naturally in the world usually follow a normal distribution. Ages not so much, especially for tablet users, but for now we will just assume that they are normally distributed. So we will go in the normal distribution. We will assume the standard deviation to be 15 since we are talking about individual tablet users. And the question is more than 30 years. So we are going to look for a probability in the upper tail which is greater than little x. And for the little value of x, we want this to be 30. So the answer here would be that the probability is 60.51%. The instructions indicate that we need to take a screenshot of the graph produced in Art of Stat and paste it in the indicated area, resize the image to fit the dedicated area of the Excel spreadsheet. So I'm gonna get my snipping tool here. Make a habit of taking, including the title of the app that you're using. Also, very importantly, if you have a table underneath your graph, include that in your screenshot. And all projects require that the left pane is showing. So include the left pane where we can see what inputs you have entered. And then let's paste it here and resize. So let me try to do that. Okay, here we are. So let's continue with the description of the project. Part B says use the function norm.dist parentheses the value of x, then the mean, then the standard deviation, and then cumulative with cumulative equal to true, to find the cumulative probability for x equal to 30. In C16, enter the value of x will be 30, and in C17, use the function with locations of the variables and not the actual values to find the cumulative probability. So let's try that. So remember that this Excel project is going to imitate what Art of Stat does, and in Art of Stat, you enter the mean, the standard deviation, and n, and then you enter the value of x. So the value of x here is 30. And then we are asked to in C17 use the function normal dot distribution with locations of the variables to find the cumulative probability. So equals norm dot dist. So here is the function. They want x first, location, don't type it in, so just click on the 30, put a comma, then they want the mean. The mean of the individual ages is up here, comma, then they want the standard deviation of the individual ages is in C3, comma, and then do we want a CDF? And the answer is yes, we do. So true over here, and then close the parentheses and press enter. After that, it says, is this the answer we were looking for to answer part 2a? So when we used Art of Stat, the probability that we found was 60.51% or 0.6051. It was not 0.394863. So the answer is it's not the same. That's not what I wanted to answer the question. Why is it not the same? Type your answer in the area starting in B18. So why is it not the same? Because the CDF of a value of the variable actually gives us the area in the lower tail. So what we did obtain is this other probability of being less than 30, 39.49% or 0.3949. So what you want to write here is that the CDF that is produced in Excel actually gives us the tail, the probability in the lower tail. And for this reason, it's asking you to also enter a mathematical expression for the probability found in C17 with a normal distribution function. So this has been left empty, blank, and you have to fill it in, and it is this cell over here. And this will be the probability x will be less than 30. And that will be your explanation also in the area starting at B18 for you to explain why what you found is not what you wanted. So how can you use the answer produced by Excel and the normal distribution function to answer the question that Art of Stat does when you select the upper tail probability? So how can we find 60.51% from the 39.49%? The answer is these two add to 1. Therefore, the probability of x being greater than 30 will equal 1 minus the probability that we just calculated, and that will be the 60.51%.